Okay. Hi, everyone. How is everybody doing? Thank you for choosing this session over a power nap. My name is Ashwin, and I work as a developer advocate at Redis. So for the next 15 minutes, I'm going to be talking about building faster agentic AI with AWS Bedrock, Redis, and LangGraph. So everyone's talking about agentic AI these days, right? It's kind of like the hot topic, and for good reason as well. In fact, just very, very recently, AWS announced Amazon Quick Suite. I don't know how many of you come across this news announcement. It's supposed to be this AI teammate, like a work platform that quickly answers your questions related to work and can also turn those insights into actions. And if you really think about it, that's kind of the promise of agentic AI, isn't it? Like, because we have these systems that just don't answer questions, but they're also doing things for us, right? So here's what you'll learn. We just have 15 minutes for the sessions, and I've left the 3-hour version of this talk at home. So my goal here is to show you what a complete working very usable AI agent looks like. So we'll start off with some really simple background, what's an AI agent and why is all this buzz going around, and then we'll go into some key considerations, and then I'll just show you a demo of that in conversational commerce, and then we'll do some technical deep dive towards the end, right? Okay, so let's get started. So when we talk about AI agents, what do we actually mean? I know a lot of you people have come across this term over and over again, but to me, it just feels like, when you ask, depending on who you ask, every one of us holds a different mental model of what an AI agent is, right? So here's how I like to think about it. An AI agent is a system that uses a large language model to decide the control flow of an application. Okay, so it is basically an LLM with capabilities that goes far beyond just searching for information or just merely cosplaying for Google search. So it's not just a chatbot that responds, it's actually a system that can actually do things for you. So think of it this way, right? So ChatGPT is like having a really smart consultant who can give you advice. Whereas an AI agent, on the other hand, is like having that assistant who can not only give advice, but then they can also work on that advice, right? They can execute it. So for example, book that hotel room, file that support ticket, or update that database, right? So here are some examples behind me, the differences between a chatbot and AI agent. So you have, for example, a use case like customer support. A chatbot would just tell you, like, here's how you reset your password when you ask it. Whereas an agent could actually send a password reset email, right? Similarly, for shopping, you might have a chatbot that just gives you a bunch of results and says, here are the items. Now do what you do with it as you please. Whereas an agent can actually do much more than that. It can actually add items to the cart. It can initiate the whole checkout process, and it can actually buy things on your behalf. And similarly, you have many other use cases as well where agentic AI can do things for you. So now, I know we've talked about this, and you probably are aware of some of the details, but every AI agent has 3 fundamental, might say, building blocks or components, right? One is the memory layer, and the large language model layer, and then there is an actions or a tools layer, okay? So let's talk about memory. So if you talk about a travel agent example, short-term memory knows that you're currently planning a trip to Mumbai or Pune or Bangalore. Long-term memory knows that you are going to prefer window seats, you're probably vegetarian, or you always prefer morning flights. So one short-term memory, that is going to be session-specific. And then the long-term memory, that's going to persist across sessions, right? And then you have the large language model reasoning module. So that's going to take all of the context from memory, and it's going to analyze your current situation. So when you ask, for example, find me a good restaurant, so the reasoning module is considering, like, what cuisine do you like from memory? What's nearby? And what's the budget, based on your previous conversations? What time is it? Is it, lunch or is it dinner? So it's not just doing pattern matching. It's actually reasoning through its decision. It's making decisions about system behavior. And finally, we have the actions or the tools module. And this is the key difference, the crucial difference between a chatbot and AI agent is this part, the actions and tools model, because that's what makes the agent useful to be able to do things for you. And so now, broadly speaking, you can think of this actions layer or this tools layer as broadly 3 categories. You have like API integrations, right? Maybe you might have an agent and ask it, hey, please check if the product is in stock. So what is it actually doing? It's actually making a database query, right, in the behind, or it's actually hitting an endpoint. So similarly, you have digital interactions. Maybe it's updating a UI, maybe it's sending an email, and it can also control physical hardware. Now, this is where it gets a little sci-fi, right? But it's actually real. So imagine you have like, a robot arm in a warehouse or something, or maybe you have a smart home or a system that's adjusting your thermostat. So all of those are within the realms of possibilities that an AI agent can do. So now, with that being said, I'm going to show you how all of this that we just discussed so far works in practice. So show of hands, how many of you know vibe coding? I guess all of us, right? Like every one of us. So I'm going to show you something called vibe shopping today. It's just a really quick POC or demo. So what I have with you is a shopping assistant that's going to demonstrate all the principles that we described. And for that, I've used AWS Bedrock, Redis, and LangGraph. And after the demo, I'm going to walk you through like how these components fit in together. Okay? So I'm going to, let me just do a full screen for a minute. Okay, hopefully you can see my screen properly. So this is a grocery AI chat application. Now, before I show you that in action, let me pull back the curtain. So I'm running this on my on a Node.js server. And this is Redis Inside. It's our free developer tool that lets you see exactly what's happening inside Redis. So I have like a lot of products that are stored inside Redis. And you have a lot of metadata about those products, like ID, name, description. And then you also have towards the bottom, you can see product info embeddings. So that's the embedding information that captures the semantic meaning of what the product is. So when somebody is going to search for tiffin box, food carrier, or lunch container, they're very likely to see that product that you just saw. Okay? So we have thousands of real products like that across all categories, kitchen items, fresh produce, groceries, you name that, you'll find in a real store. We have all of that. So here are some of the categories. So back to our application. So what I want for you to watch is, I'm going to type, what do I need for pasta? Okay, that's vibe shopping. Okay, so I want you to watch how the system understands context and finds relevant products, even with a vague description, and gets faster over time. So we started with the cooking question. So the AI is thinking through the recipe of pasta, understanding what pasta requires. It's using a bunch of tools. And it's trying to query your database for actual ingredients that are actually existing in the database that we just saw. So it's almost done. So it's found like few items, as you can see. And now, if you see over here, you have a complete list of ingredients with actual products, with IDs and prices that you can buy. And the AI is also allowing you to follow a link to the product description page to find more information about that. Okay, so now we will go back to our Redis Insight, and we will see how we are maintaining the session conversation history. So every message, both from the user and the assistant, is stored in order. As you can see over here, we have chat and we have cart. The cart is currently empty because I haven't added anything to the cart yet. But notice that in the main chat, I've stored both the messages from the agent and also from me. And now I'm going to add something to the cart. So notice that I want to add pasta and I want to add cheese to my cart, okay? So, but I'm not mentioning anything about cheese and pasta. I'm just saying add items 1 and 4 to my cart. Okay, so notice that it's using the product ID from the previous search. So it remembers our conversational context. Okay, so this is context engineering in action. So notice that it's added those product IDs to the cart. If you can see, 658 and 1328, those are the product IDs. And it's actually added the items that we wanted to buy. So this is context engineering in action. And we have the summary of the cart that gives you the total items, the price details, and also how much discount, and it's prompting you to add more if you want. So now, what I'm going to do is, if you notice, items, they've actually been added to my cart database with all the relevant information. Okay, so now back to, I'm just gonna do a quick query to my database, what's in my cart. So it's going to look up my database, and it's going to list out the list of product items. So this is session persistence, by the way, across the entire conversation. It knows who I am, it knows what I've been doing. So now, is there a way to make it even faster? So I'm gonna show you how to make this even faster, because this took some time, right? It took some time to process the query, and so I've logged in as Ashwin in this window. So now I'm going to go to a different tab. I'm going to ask a very similar question. So I'm going to ask the same question phrased differently. I am looking for pasta ingredients this time. Last time I asked, what do I need for pasta? This time I phrased the question differently. And notice, in less than a second, the agent has returned me the response using something called semantic caching. So this is semantic caching in action. So it need not hit the large language model and consume a bunch of tokens and latency, right? So it was very, very fast, less than half a second. So this is semantic caching, one of the many applications of Redis as a database. And this is how my conversation looks like. So this is the content. And over there, that's where I've saved semantic cache. So I've saved both my prompt and the response in vector embeddings, and that allows me to query and find answers to questions that have been previously answered before as well. Okay? So now, not only that, now we can also use AWS guardrails to screen requests for appropriateness. So this is another way of reducing token cost. Okay? So before any expensive AI processing, watch what happens if I'm asking a non-shopping question. I'm asking, well, how do I deal with a difficult mother-in-law? Okay, maybe, I don't know, who knows, maybe people are having issues. So notice what's happening when I ask this question. So there is a front desk agent that sits right before the shopping agent, and it detected and said that it's a guardrail. So I've kept a guardrail to detect any irrelevant requests. And it said, let's keep things shopping focused. It can't help you with your mother-in-law. Okay, so that's a little bit about the demo. So AWS Bedrock. So for the large language model itself, I'm using Bedrock foundational models to implement this. And with guardrails in the picture, so it allows me to screen requests for inappropriateness. And we can automatically add all of this in our AWS Bedrock console. So content safety, topic restrictions, you name it. So that's it. So now, here are some performance statistics to show you the first time that we asked the question, we did not have the response saved in semantic cache. So it took a long time. It took almost like 30 seconds. Now, I'm on my mobile data, so it's taking far more longer than anticipated. But then notice the second time I asked the same question, looking for pasta ingredients. Very similar questions, phrased slightly differently. It took less than a second, and you saved a bunch of tokens in the process. So initially you had like almost 7,000 tokens for both input and output. And the next time, there's barely any tokens registered also. So this is LangSmith, by the way. So if you're using LangChain or LangGraph in your application, it's basically plug and play. You just add an API key in your LangGraph application, and you're good to go. So now, so Redis, how many of you use Redis in your organizations? Right, so I guess most of us are familiar with the standard caching use case, right? So, but Redis has evolved beyond the standard cache to something called semantic cache. So this is how it works. So when you introduce a large language model, whether it's customer support, shopping assistance, or technical documentation, your users are going to ask the same questions over and over again. Like what's your return policy? How do I reset my password? Or what are your business hours? Or how do I export to PDF? So every one of those identical questions need not trigger a full API call with the same computational overhead and the same processing time. So you can serve your users much faster with semantic caching in the picture. So where it understands that what do I need for pasta and what are the ingredients for pasta? They're basically the same question. And this is this is the architecture diagram that I use for this particular product. You just saw it working now. Notice that every query here follows a cache first pattern. Okay, so before we do even any expensive AI processing, we're checking in Redis LangCache. Redis LangCache is, by the way, semantic search, semantic caching as a service offered by Redis. So we are checking in Redis LangCache, in semantic cache, if we already know the answer, if this question has been answered before. So if it's a hit, then we just send the cache response. If it's a miss, then we trigger the full AI workload, right? So in the AI workload itself, we have a front desk agent that's going to do the screening that we just saw earlier for appropriateness, and guardrails, Bedrock guardrails handle this automatically. So PII detection, custom filtering logic, you name it, you can do all of that. And then next it does an agent handoff to shopping agent. This is your personal shopper, so this is where the real intelligence is. So here I have made various tools available to my model, right? So I have a tool for product search, I have a tool for cart management, and recipe, finding ingredients for recipe. So, and finally, once it's done all of that, there is a data compliance agent, and there is a PII guardrail. So before you save something to semantic cache, you want to ensure that you're not saving any highly confidential information, like your user might enter in their email or a credit card information, whatnot. So we are having a PII guardrails that's going to remove and sanitize all of that before it's made available back to Redis LangCache. And LangGraph handles all of this and orchestrates all of these tools for you. So it's going to handle the complexity of coordinating multiple tools, managing state between calls, and decide when the workflow is complete. So, and the beauty of this approach is it gets faster over time. So every user, makes it better for everyone else who comes after them. So if I've asked the same question, there's a good chance that somebody else might ask the same question, right? So this is how, it's a very small code snippet because we just have a very short time. So using LangGraph with AWS Bedrock allows you to import multiple Bedrock foundational models into your application. So I've used Cloud Sonnet 3.5 for the reasoning and conversation, and I've used AWS Titan embeddings for semantic search, and all of this is available on Amazon. So different models for different jobs, all through one single endpoint. It makes it really easy to test your guardrails, which you can just apply later in your code base. And this is how a very small code snippet, we can talk about this more later after this session, but at its core, LangGraph, this is how it looks like. It's really easy to create workflows, structure them, and pipe different nodes, inputs from one node to the other. Really straightforward. And when you do all of this, the key job to do is something called context engineering. How many of you have heard this phrase, context engineering, before? Yeah. So context engineering is really the job when you're building AI agents, right? So because every decision your agent makes should be informed by context. Okay, what happened before? What does the user prefer? What worked previously? What does the system know? What tools does your agent have? So every agent decision needs context from multiple layers. Okay, immediate context, what's happening right now in this conversation, and historical context as well. So, and Redis allows this availability of context to your AI agents in very, very fast time, in almost real time. So with Redis providing your sub-millisecond context, your agent can make informed decisions really, really fast, okay? And so here are the key takeaways and quick recap. So let me just revisit what we just demonstrated today. So in this demo, you saw an agent. What you saw in the agent was something that could enable you to do very interesting use cases like vibe shopping. So the agent chose what tools to use, what products to search for, and how to respond contextually. And to enable building AI agents, it needs more than just a large language model, and this is where your frameworks and tools come into the picture. So you have production-ready frameworks like AWS Bedrock, different models for different jobs, and we have guardrails. If it's anything sensitive information that you're capturing from your users, you would want to ensure that you're sanitizing the inputs appropriately. And Redis is a great way to do that. It helps make your context management clean. It has a lot of data structures. Like you just saw, JSON is one of the many data structures that Redis supports, vector embeddings as well. And this approach now unlocks possibilities that you've not seen before, like conversational commerce and cost-effective AI. It's going to deliver intelligence without breaking your budget. And a faster user experience is really a much better user experience, right? So it's a pattern that you can apply to any domain, not just for shopping, but for any domain where users need intelligent assistance from models with memory and context, and provide your users with quality answers. That's a wrap on the session. I know 15 minutes barely scratches the surface of what's possible here, but if you're curious about how to make this work for your specific use case, or you just, I don't know, you just want to geek out on AI architecture, or maybe you just want to try running the demo, you want to see how the code looks like, so the repository is available on GitHub, so I can share that also with you. So come find me after this talk, or feel free to reach out. I'll be here around for the rest of the day, for the rest of the event, and yeah, always happy to chat about this stuff. Thank you.